Hello guys, welcome back to our YouTube channel Tutorial Home My Electrical. In today's video, I will discuss some formula regarding electrical machine that will be helpful for your upcoming exam. You all have to make sure that you all remember this formula. So let's start today's video. In today's video, we start from DC generator. In DC generator, you all have to remember the formula regarding 5 types of DC generator. One is separately excited DC generator, shunt generator, series generator, short shunt compound generator, and long shunt compound generator. So let's start from separately excited generator. In separately excited generator, V is equal to Eg minus IRA minus brush drop. Here V is terminal voltage, Eg is back EMF, IA is armature current, IRA is armature resistance. Next, shunt generator. Shunt generator, also called voltage operated field generator. Here in shunt generator, the formula of IA is ISH plus IL. IA armature current, ISH shunt field current, IL load current. And V is equal to Eg minus IRA minus brush drop. Next, series generator. Series generator, also called current operated field generator. In series generator, V is equal to Eg minus IA into RA plus RAC minus brush drop. Here RAC is series field resistance. Next, short shunt compound generator. In short shunt compound generator, IA is equal to ISH plus IAC. ISH is shunt field current, IAC series field current, and generated voltage V is equal to Eg minus IRA minus IAC into RAC minus brush drop. RAC series field resistance, IAC series field current, IA is armature current, RA is armature resistance, EG is back EMF. Next, long shunt compound generator. In long shunt compound generator, IA is equal to ISH plus IL. Here IA is armature current, ISH is shunt current, IL load current, and generated voltage V is equal to EG minus IA into RA plus RAC minus brush drop. Here in long shunt compound generator, you noticed the formula of generated voltage is same as series generator formula. Okay. Next, you have to remember the relation between lap and wave winding. The formula of relation between lap and wave winding is AL square into RL is equal to AW square into RW. Here AL summon number of parallel path in lap winding. AW is number of parallel path in wave winding. RL lap winding resistance, RW wave winding resistance. Next, you have to remember relation between electrical and mechanical degree. Electrical degree theta is equal to P by 2 into theta m. Here P is number of pole. Next, you have to remember the formula of leakage coefficient. Leakage coefficient lambda is equal to total flux by useful flux. Okay. Next, you have to remember the formula of demagnetizing ampere turn per pole. Demagnetizing ampere turn per formula, the formula is AT is equal to ampere turn demagnetizing per pole is equal to 2 theta E divided by 180 degree into IA divided by A into Z by 2P. Here Z is number of conductor. Theta is electrical degree, IA is armature current, A capital A is number of parallel path, and P is number of pole. In next page, you have to remember the formula of cross-magnetizing ampere turn per pole. The cross-magnetizing ampere turn per pole is equal to 180 degree minus 2 theta E divided by 180 degree into IA by A into Z by 2P. Next is total ampere turn per pole. Total ampere turn per pole is equal to IA by A into Z by 2P. You can notice the formula of demagnetizing ampere turn per pole and cross-magnetizing ampere turn per pole. The sum of demagnetizing ampere turn per pole and cross magnetizing ampere turn per pole is equal to total ampere turn per pole. Obviously, next you have to remember the formula of compensating winding ampere turn per pole. The compensating winding ampere turn per pole is equal to pole arc by pole pitch into Ia by A into Z by 2P. Next, you have to remember the reluctance voltage in commutation. What is the magnitude of reluctance voltage in commutation? The formula of reluctance voltage in commutation is 2Li by Tc. 2Li by Tc. Here L is inductance, I is current, Tc is time of commutation. Next, you have to remember some characteristics and their relation. One means what is open circuit characteristics relation. So, what is open circuit characteristics? Open circuit characteristics show the relation between Eg and If. Here Eg is generated voltage, Eg is back EMF, and If is field current. Next, internal characteristics. Internal characteristics show the relation between Eg and Ia. Eg means back EMF and Ia means armature current. And next, external characteristics. External characteristics show the relationship between Vt and IL. Vt means terminal voltage, IL means load current. Then load saturation curve. Load saturation curve show the relationship between Vt and If. Vt is terminal voltage, If is field current. Then we start in DC motor. In DC motor, EB by back EMF. In DC motor, EB is P phi Zn by 60A. Here P is number of pole, phi is total flux, Z is number of conductor, N is RPM by 60A. A is number of parallel path. In DC motor, torque generated TA is P by omega. Here P is power, omega is speed in radian per second. T is equal to P by W. Also, T is equal to EBIA 2 pi N. Here EB is back EMF, IA is armature current, and N is RPS. Again, torque is equal to 60 EBIA by 2 pi capital N. 60 EBIA 2 pi N. Here N is speed in RPM. Also, T is equal to K phi Ia. K is constant, phi is flux, Ia is armature current. So, T is equal to K phi Ia. So, T proportional to phi Ia. In case of shunt generator, in case of series generator, phi is equal to Ia. Means, as in series generator, armature current is flow through the field, so phi is equal to Ia. So, in case of series generator, T is equal to Ia square. Next, you have to remember the formula of condition for maximum power developed. This formula is important. Condition for maximum power developed. The formula of condition maximum power developed is EB by V by 2. Here EB is back EMF, V is terminal voltage. Then the relation between back EMF and rotor speed of DC generator. The formula of back EMF and rotor speed DC motor is EB2 by EB1 is equal to phi 2 into by phi 1 N1. You can notice from this formula that back EMF is inversely proportional to the multiplication of phi into N, means EB proportional to 1 by phi N. Okay. In next page, you have to remember the various tests of DC machine. This topic is important. Here you have to remember, the name of the test and the use of this test. Means Swinburne test, Swinburne's test is also called no load test, used for determination of constant loss. Constant loss means iron loss. In iron loss, there is eddy current and hysteresis loss. Next, you have to remember retardation test. It is also called running down test. It is used for determine stray loss in case of DC shunt machine. You have to remember this test is only for DC shunt machine. It is used to determine stray loss in DC shunt machine. Next is Hopkinson test. Hopkinson test, also called generative test, hit run test, and back-to-back test. It is used to determine the performance of machine regarding commutation and temperature rise. Next, you have to remember field test. It is also called series motor test. It is used for determination of stray loss in case of DC series machine. This test is for DC series machine and retardation test is for DC shunt machine. Field test is also used for determination of stray loss in DC machine, but it is for DC series machine and retardation for DC shunt machine. Next is brake test. Brake test is also called direct test. It is used for determination of efficiency for small motor. Brake test is used to determine the efficiency of small motor. Next, open circuit test. Open circuit test is used for determination of coal loss. And next is short circuit test. Short circuit test is used for determination of copper loss. Next, you have to remember the formula of relation between speed and torque of DC and parallel connection. Relation between speed and torque of series and parallel connection. So, N parallel, speed in parallel is equal to 4 times of NAC. Next, T parallel is equal to TAC divided by 4. So, thank you. In next part, I will discuss the formula regarding transformer, auto transformer, induction machine and single phase machine. Till now, thank you, bye. And if you like this video, please like, subscribe and share this video to your friend, because this discussed formula is very important. This may help you in your upcoming exam. So thank you for watching, and I will provide the PDF of this video in my WhatsApp channel. The link of the WhatsApp channel is given in description below. So good night, bye.